recording. Okay. Yes, so last class, we discussed more on interface. And for interface, we discussed that it has like a constant value. It can hold a constant value. It can also hold abstract method. And it also implement static method, as well as we call default method. Okay, and interface, if you recall, it doesn't involve any inheritance relationship, okay, because it's more focused on methods. That's its concentration, etc. So different category of class can all implement the same interface, okay, interface. And we also, I remember we also started discussing this house example class. And for this class, it implements two interfaces. So if you want to implement multiple interface, you can list all of them up and use a comma to separate them, okay? And for this house class, it implements clonable and comparable interface. So let's see, for clonable, then generally speaking, then you need to implement the clone method. But remember, okay, clone method not clonable. So it's not from clonable interface. So always keep this in mind. This clone method you override, basically it's from object class, Java's super root class. So objects, okay. And so basically clonable interface in Java, it doesn't have a single method. This kind of interface is called a marker interface. Marker interface. It's just states that if your class implements this marker interface, then this type of class has certain features. And that feature is going to be supported by the method that it overrides. Is it, in this case, from the object class, it's a clone method. So that's called a marker interface. Okay, so it just represents, okay, this house then is clonable. It owns this feature, okay? So that's a marker interface for clonable. And then the second interface is called comparable interface. For the comparable interface, it just has a single abstract method. So it's Sept as a single abstract method. So this kind of interface in Java is called functional interface. So it just has one, okay, because later on, when we learn lambda expression, anonymous interface, anonymous class, lambda expression, we are going to see this concept of functional interface. Just remember it's related with the SAM concept, okay? And also for this house class, so for ID and area, so these two instance variable, the type, primitive type, primitive types, okay? And for the third one, for the third instance variable, what's the type? The type is reference type. Reference type, okay? And for the clonable, whenever we say clone, then it's involved deep copy or shallow copy. Is it? So for deep copy, then that means not the, so the object is going to be cloned at a different location. For shallow copy, then it's just an alien thing, is it? But in this case, when we said we want to have, so for the clone, we prefer it to generate a deep copy one, is it? So the deep copy one, okay, it's not just the house be cloned at a different location. The build time should also be cloned at a different time. Okay, so over here, to achieve a real deep copy for the house, then it involves two levels. One is for house, then the other is for the when built instance variable. It also needed to be copied, okay, and a deep copy. Because the clone method from object class, that's not a real deep copy one, okay? Okay, so over here, then for the constructor, it's pretty straightforward, okay? The get method, and then next, let's see, this clone, is it? And this clone, we already said it's from object, so the return type is object, okay? And we do the override, is it? Because the clone method in object class is protected, okay? So we can override it, but it's a shallow copy. If you here just call super.clone, then it's a shallow copy. It's not a real deep copy one because data not cloned, okay? So the concept then in this scenario is, so here we have that stack memory, and here we have a heap memory. Heap memory, is it? So suppose you have a house, you call the new house. New house, is it? So then it's going to create a new house. So it has ID area and the date time built is it when built. But this when built is reference type. So it's another object that it's going to reference to, is it? And when we call the dot clone, when we call the dot clone, what is created is ID area, is it? And it's just when built, is it? And then this when built is what? This when built is also pointed to this when built. So this single when built is shared, is it, by both of them. So this is not a real deep copy. A real deep copy is, you shouldn't let it refer here, is it? you should let it refer to a new date. Is it a new building date? So that's then in this case, this is a deep copy. Okay, this is a deep copy. So how do we achieve the deep copy? Then what we can do is, okay, so this super data clone part, this will take care of ID and area, the primitive type values. Okay, and for the reference type, the date, then you need to explicitly call the date's clone method. Okay, then you cast, because the clone method return type is one object. So that's why here you need to cast it to date type. Is it? Then you assign it to, then you return this. So then this is a deep copy. So that's about this version implementation. You can also do the other version is you create a new house, is it? And for its date, you just call the new date. Is it called the new date? And then you set when builds time to when builds get time. Is it? You can call the set time to change it. So that's just another multiple ways, okay? But anyway, the goal is we want to have the deep copy one, okay, deep copy one. So this is regarding clone. And then let's take a look the driver part for the clone. So the driver part for the clone, let's first see, we have two houses, is it built? So the second one is the first one's clone, is it? And over here, if we take a look, we use the first version, we use the shallow copy, is it? Shallow copy, okay. And this equal is to check what? It's a reference check. And this is contents check. Okay, not necessary to be in the same location for that. This two must be at the same location. Okay, so that's, we can run it to take a look. So that's, so definitely they are not in the same memory location as it. And for this one, it is true, okay. And then this part of the array list, then we don't need, we already learned array list. This is pretty similar as what we previously saw, is it? Okay, so that's regarding the clonable, okay. And what next one, let's take a look at the comparable interface. So for the comparable interface, what that abstract method defined in comparable interface is the compare to method. Compare to method take another object as its parameter because it's compared to objects. Okay, this basically kind of, because for primitive data type, is it, you can use like equal for comparison, like 100 equals to 200 as a primitive data type, is it? You can directly use this equal for comparison, is it? And greater than or less than, is it? But for object, we cannot directly use the greater than, less than, is it? And then we need to do some definition based on our own criteria. So here we define the rule for comparison. We define the rules for comparison, okay? So over here for our house, what is the rule we use? We use area. We use area first, is it? And if the first, so if this area comes from object self, is it? If it's greater than the other object, then you return 1. Otherwise, you return 0, and or return -1. And if both are equal, then you return 0. So this is for this compared to. So you said for house, I just want to use area for comparison in this case, okay? And what the other two methods in this class, the toString we already saw numerous times, okay, for objects. And for equals, the equals method also from object. So here you just override it. So you will determine how you want to make the two objects, this equals be true when you perform the comparison, etc. So over here it says, okay, I want to consider ID, area, and the build date. All three of them need to be the same. Then we consider those two objects, two house are equals to each other. Okay, so that's what is the definition. And for this compare to, then let's take a look at the driver part. Okay, for the driver part, over here, this is an array. The array type is a house. Okay, and the capacity, there are 3 elements, 3 house. The default one and the 2 other ones, the 3 one. And then we call this arrays, is it? And we call the sort method, is it? We call the sort method. We call sort method and then we plug in array, is it? But whenever you just think about it, whenever you do sort, it's based on some comparison. Based on some comparison, is it? So what a comparison here we based on, is it? That's why it's that comparable interface. Is it? And the comparable interface, it's implements the compare to method. So basically it's going to, each object is going to compare with the other based on that compare to method. Then it's going to be arranged in some order. Okay, so that's why this sort will work. That's because the comparable interface is already implemented on house. And this compare to method already defined. And then you can determine, is it, okay, house 1, is it less than house 3? Maybe in this, and then house 2, something like this. Is it? Then you can do sort, okay? So that's regarding this sort. And for sort, for over here, you sort an array, you plug in an array, etc. And we can also sort array list, okay? For array list, then you can call the sort method from collections class. Then here, you plug in an array list, okay? And what the next part to try to do is just to output each of the house information. Okay. Then next, let's see the running result. So the running result in this case, we can see the first is that using that arrays dot sort. Is it? And you can clearly see it does sort by the area. Is it? And the second one from the collections dot sort. Is it? It's also based on area. And areas from what? From what we defined in that compare to method. Is it? So that's our, you want to use area as a rule for comparison. Okay, for comparison. Okay, so that's regarding this example. And the next, let's take a look at the official Java document about clonable and comparable interface. Okay, so over here, this is for that clonable interface. Okay, clonable interface. And this clonable interface, that what over here says, this just indicate that object clone method legal for that method to make a field for field copy instance of some specific class. This is what this clonable interface indication, okay? And the objects is that invoking object class on instance if your class doesn't implement clonable interface, then this exception will be thrown. Okay, will be thrown. So that's why you needed to, whenever you override the clone method, then you need to also implement this clonable interface, even though this interface does not contain the clone method. Okay, so it forces you to override objects clone method. So this is what we call it a marker interface. Okay, interface, because otherwise it can throw that exception. Okay. And if we take a look more at this clone interface, you can clearly see that just give us some description, and it doesn't contain any method. Just see for the clone method, then we need to see object clone method. Okay. So this is a concept regarding marker interface. And then next, let's see the comparable interface. Okay, the comparable interface also over here, there is another very important concept is for the compare to method. If a class implement compare to method, normally what we see is this is called nature comparison method. Okay, because later on we will learn another one. Then it's something else. Okay, so over here anyway, it's nature comparison method. So just keep that in mind. And the nature comparison method, then in Java, like the collections and arrays, both of those two classes, their sort method, as in our example shows, they use this natural comparison method for the sorting. Okay, for the sorting. And then later on, it says object that implement this interface this can also be used as key in some sorted map or sorted set. Okay, that's later on. We will also learn. Okay, we will also learn. So that's regarding this comparable interface. Okay, and the comparable interface, and also over here, if we read more, it's a nature ordering for a class. Normally, it also needs to be consistent with whatever you define for the equals. Okay, equals. So if use the compare to return 0, okay, then the equals should also be the same. Okay, so generally speaking, that's, we need to generally make an equals and compare to be the same. Okay, so that's consistent. Okay, what we defined when we define both of them. And then let's take a look for comparable interface. Has this compare to method. That's the only method. Is it abstract method and not implemented? And here it gives us a detailed explanation about the compare to. Is it? So that's why we see this comparable interface. It just has a single abstract method. So this interface, we call it a functional interface. So always keep this in mind, okay? Okay, so basically we finish the discussing about interface also, okay, interface also. So next, let's just do a quick review, okay, regarding all what we have learned so far. Is that so far what we have, so all of this related with objects. Because over here we discuss OOP programming. So object oriented programming. Is it? And object oriented. So object, we learned the concept about class. Is it a class? So class is just some kind of placeholder for a category of objects. Is it? And generally speaking, it has instance variables and the instance method. Instance method, is it? And of course, class also support class method. So that's what we learned for class. And the class is the instance variable. It has primitive type and a reference type. Is it a reference type? And for class, when we define instance variable, generally, we want them to be as private. Is it? Generally speaking, okay. And for private, it's only class itself can be accessed. Is it? Not other class can access it. So we call this feature as encapsulation. Is that information hiding? Okay, and but be careful, okay, with reference type of instance variable. Okay, and you define as private, is it? But we said the instance method, generally speaking, you also have accessors and mutators. Is it mutator? And if your accessor generally also public, is it? And the public, if you provide, you return that private instance variable, then it's violate encapsulation. So that's not a secure coding recommended. Okay, so not secure coding recommended. Is that recommended? And similar for mutator. Okay, so you need to be very careful. Okay, so this is regarding the first concept that we learned regarding object. Okay, the object also, of course, need a constructor to create objects. Is it? Then later on, we learned inheritance. Okay, inheritance is describe what is a relationship. Is it a superclass object? Of course, it can is also a subclass type. Is it? And of course, so it's inheritance. And inheritance then it defines the superclass and the subclass relationship. Is it? I use the keyword extends. Okay, and superclass then can have some properties as protected. Is it? Then protected subclass can access. Is it? And involving the superclass, then we always have the keyword super, is it, to reference it. And also keep that in mind. Whenever you do inheritance, then it involves override. Is it? Method override. Okay, so subclass can override a superclass's method. Is it? And so this is regarding the inheritance general relationship, as a general relationship. And with the inheritance, then it also involves polymorphism. Is it? And for the polymorphism, generally speaking, is you can have like some method, the parameter type. Parameter type, it can be some super type. Is it? And then when you invoke it, then you can plug in subtype. Is it? So this is called polymorphism. Okay, polymorphism. And then regarding, because sometimes then you, within it, is it, you have the parameter, the object, some object. So here it's, suppose we call O, is it? Then when you call O some method, is it assuming like that toString method? Is it? Then it has multiple versions. Is it some from superclass, some from subclass? Is it? Then it depends on the plug-in objects type. Is it? So this concept, we call it what? We call it dynamic binding. Is it dynamic binding? And the polymorphism, dynamic binding, not just apply to inheritance. Is it superclass? For interface, we learned it's also applied. okay? Because an interface can also be used as a type. As a data type. It's a data type. It's just when you call some objects, is it? It's a method. Then it depends on which concrete class owns that method. Then it's a dynamic bind that specific method, is it? And then over here, it also involves another concept that we learned as abstract class. Is it abstract class? And the abstract class can be superclass, is it? And object class in Java is a concrete class. Be careful, okay? It's not abstract. So superclass can be a concrete class, but subclass can be an abstract class. It can also do the other way. Superclass be an abstract class, and subclass can be a concrete class. Okay, so that's all regarding of this OOP concept. So regarding OOP, the keyword that we needed to have deep understanding is encapsulation. Okay, generally speaking, involve the keyword private and inheritance. Normally it involves the protected keyword, is it? And we also learn polymorphism. And normally it's also related with dynamic binding. Is it? And inheritance, the override keyword. Is it is also kind of involved with inheritance, but it's also involved with interface. That has nothing to do with inheritance, okay? So that's just a summary of what we have learned so far regarding objects, inheritance, polymorphism, of this concept. So we complete this kind of section study. And starting from Wednesday, we will move to exception and file handling, okay? But today, let's just stop here. So